Venice, the floating city of canals, is sinking. To protect it from devastating high tides, engineers constructed a multi-billion-dollar barrier of invisible underwater floodgates. This periodic flooding is called acqua alta. During severe storm surges, the sea spills into Venice's historic squares, eating away at the brick foundations of centuries-old buildings. The city's shield is MOSE, a system of 78 mobile floodgates split across the three inlets connecting the Venetian lagoon to the open Adriatic Sea. Venice flooding is a geographic problem. The Adriatic Sea is a long, narrow funnel. When storm winds blow up this corridor, they jam water right into the closed tip where Venice sits. Three factors trigger acqua alta: normal astronomical high tides, low atmospheric pressure that sucks the sea upward, and sirocco winds pushing water north. Think of a bathtub. If you blow a hairdryer across the surface, the water piles up at the far end. The sirocco wind acts as the dryer, piling water up against Venice. To block the surge, engineers built 78 massive hollow steel gates. Each gate is 30 meters long, 20 meters wide, and weighs up to 350 tons. During calm weather, these gates are invisible. They are filled with seawater ballast, which makes them heavy enough to lie flat inside concrete casings on the seabed, letting ships pass above. It is like a hollow toy boat in a bathtub. If you fill it with water, it sinks flat to the floor. It stays submerged under its own ballast weight until you empty it out. When the tide forecast exceeds 110 centimeters, the system activates. The gates rise slowly to form a temporary seawall, keeping the high tides out of the lagoon. The gates rotate around giant marine hinges that anchor them to the seabed basins, letting them swing upward to block surges. Because they sit underwater, these hinges are forged from specialized stainless steel alloys and cast iron, designed to resist salt corrosion and wave forces. Salt water is highly corrosive, and floating sand acts as an abrasive paste inside the hinges, while barnacles try to grow over the moving joints. To keep them working, diving teams perform regular underwater inspections, and modular gates can be lifted out by giant crane barges for maintenance. The system doesn't use massive motors. Instead, onshore compressors pump compressed air through seabed service tunnels directly into the hollow gates. These casings are massive concrete boxes sunk into the seabed mud to hold the gates level and provide a stable foundation. When compressed air enters the hollow gates, it pushes the seawater ballast out of the bottom, making the gates buoyant so they float to the surface. The gates sit at a 30 to 40 degree angle, leaning forward against the incoming Adriatic waves and deflecting wave energy upward. Imagine pushing an upside-down drinking glass into water. If you blow air into it with a straw, the trapped air pocket creates a buoyant force that lifts the glass. Because the 78 gates are not physically connected, they can move independently, flexing with the waves to prevent the barrier from snapping. When the storm passes, the air is vented, seawater floods back inside the gates, and their weight pulls them back down into their concrete trenches. But closing the lagoon creates a shipping problem, blocking commercial cargo vessels and fishing fleets from reaching Venice docks. To solve this, engineers built a massive navigation lock at the Malamocco inlet, allowing cargo ships to enter even when the barriers are raised. This lock acts like a canal elevator, equalizing water levels inside the chamber so ships can pass there safely without lowering the floodgates. Smaller navigation locks at the Lido and Capia inlets handle local yachts, fishing boats, and emergency vessels during barrier activations. MOSE was a massive investment, with total construction costs reaching between US $2 billion and US $0 billion over several decades of work. Operating the barriers is also expensive, requiring an annual maintenance budget of US $30 million to use $8 million for rust and sand control. However, this is a vital insurance policy, shielding billions of dollars of historic real estate and tourism revenue from storm damage. The cost of doing nothing is far higher. A single major flood can cause over $100 million in damages to local shops, hotels, and ancient masonry. Since its activation, MOSE has successfully prevented dozens of severe flood events, keeping Venice streets dry during major Adriatic storms. But climate change brings new challenges. As global sea levels rise, the barriers will need to close more frequently to protect the lagoon. Frequent closures can block vital water exchange cycles in the lagoon. Engineers are already working on upgrades to balance protection with ecological health. By balancing engineering with the tide, MOSE is keeping Venice afloat. Thank you for watching Layman's Field. We hope to keep bringing knowledge for everyone.